Hello and welcome to our today's webinar. My name is Dennis Dietrich. I'm the sales manager at our company and I've been working for Dayton Progress since 14 years now. Today we will be discussing the maintenance and safety features of gas springs. We are delighted to have Francesco, a specialist from Special Springs, join us for this webinar. Hello Francesco, thank you for joining us today. Would you like to briefly introduce yourself?
Good morning, everyone. Hi, Dennis. My name is Francesco Bordini. I'm the R&D product manager at Special Springs. I joined the company in 2015, focusing the development of new products and providing technical support to the sales team. A special thanks to Dayton for providing the opportunity of taking part in this webinar.
Here is our agenda. I will give an overview of our gas spring program, point out potential hazards, and present the safety features. Francesco then will demonstrate the disassembly of a gas spring, show examples of defective springs, and outline possible safety protections. We offer the full range of gas springs for press and die shops. We sell springs from our parent company Mizumi, which are manufactured by our partner Special Springs in Italy. All series are shown in the image. For example, the GSV series, which is our most sold version with dimensions according to VDI 3003, which is used by all automotive OEMs. Our gas springs are filled with nitrogen, typically at a pressure of 150 bar. Misuse due to human error can cause a catastrophic burst of energy. For example, the rod of a GSV 1000 can be ejected to up 443 meters at a starting speed of over 330 kilometers per hour. That's like dropping a steel plug from the top of the Empire State Building. This highlights the immense stored energy inside every gas spring. To prevent accidents, our gas springs are equipped with appropriate safety and protective features. Here are the most important functions. OSAS, overstroke active safety with the OSM, the overstroke marker. USAS, uncontrolled speed active safety, and OPAS, the overpressure active safety. Let's take a closer look at the safety functions. The enlarged view shows the assembly between the bushing and the cylinder. The first stroke is executed under normal operating conditions. The second stroke is too deep and the OSAS safety feature self-activates. The pressure is released in a controlled manner. There is no danger to nearby personnel. No parts are thrown around. The safety component is installed in the base of the cylinder. In this case, it's a plug with a predetermined breaking point that allows gas to escape once it's triggered. The gas spring has been compressed over the nominal stroke, and the safety protection led the gas to be discharged. In the pictures we can see the overstroke marker is damaged and the safety plug has been triggered and compressed. USAS is the combination of a deformable part of the bushing in contact with the retaining ring and discontinuous on the internal body surface. The first stroke is performed under correct operating conditions. From the second stroke onward, the stripper blade jams. It is then released by the operator or by the continuous press cycling, resulting in an uncontrolled return stroke of the gas spring rod. Repeated and uncontrolled return strokes activate the user's safety device. After the activation, the guide bushing position is significantly further from the cylinder body. The pressure is released in a controlled manner. There is no danger to nearby personnel. No parts are thrown around. Here in the image, we can see the incorrect position of the piston rod and the guide bushing. The guide bushing position is significantly further from the cylinder body. OPAS is the combination of a rupture plug and an exhaust milling outlet on the lower contact surface of the gas spring. In this example, a lubricant is being used for the stamping operation, in direct contact with the gas spring rod. This allows the lubricant to enter the cylinder, reducing the available room for the nitrogen, and this increases the pressure until the OPAS safety device is activated. The pressure is released in a controlled manner. There is no danger to nearby personnel. No parts are thrown around. Here we see the lubricant that has leaked out at the base of the spring and the plug where the predetermined breaking point has been triggered. In case of safety feature activation, it is not possible in a simple way to know what is the real damage on the gas spring components. Hidden damages, together with the working failure, stress on the components, can lead to a dangerous cylinder rupture. Therefore, it is always necessary to replace the gas springs after a safety feature activation. Now Francesco will show us how to disassemble the gas spring using the GSV as an example.
The next video will show briefly the necessary operations for the maintenance of a GSV gas spring. At first, we remove the overstroke marker. It must be broken with a screwdriver and then removed using the plier. We can proceed then removing the plug and discharging the gas using the discharging tool. The gas flow must be directed far from the operator. To check the cylinder is completely discharged, we compress the roll, avoiding the full stroke to prevent the activation of the overstroke safety device. Then we remove the valve using the proper tool. On the end press, we can press down the bushing using the dedicated nylon tube. The retaining ring is now visible and can be safely removed using a plier and a screwdriver. Then the rod can be pulled to the fully extended position, and it can be disassembled using the extractor tool that pulls the bushing in the correct direction, avoiding it being stuck in the body. We can remove the war bushing from the rod and proceed with cleaning the rod and body. In this stage, it is important to check that the components have no damages, such as heat or scratches. In the maintenance kit, we can find a new bushing, a new overstroke marker, grease, oil, and the valve. The valve can be assembled on the body using a special screwdriver. Then we put inside the body the lubricating oil. We proceed then, applying some grease on the main seal and cap. Then we mount the bushing on the rod using the end press. And we apply some grease on the bushing static seal. The body must be also lubricated with grease, in particular on the safety grooves. We place the centering tube on the top of the body and position the bushing and rod inside it. Then we put the retaining ring inside the centering tube. Finally, we press down the retaining ring and bush in the cylinder spout using the positioning. When the installation of the ring is correct, we hear a click noise. Now the tubes can be removed from the body and we can pull out the rod. For this operation, we use the extraction tool. Once the rod is completely positioned, we can proceed with charging using the charging device. We close the venting valve and we open the supply valve until the desired pressure is reached. Then we close it and open the venting valve to release the residual gas from the charging device. After the cylinder charging, we check the initial force is correct on the first step. If the cylinder is correctly charged, we can proceed mounting the protective flag. Then we mount the overstroke mark. The V shape must be in the same position of the safety grooves. For the installation, we use the positioning tube previously used for the retaining. Here also, a click noise is a sign for the correct installation. And maintenance is now complete. Contamination is one of the most common reasons for the failure of a gas spring. We will see some examples, followed by the possible solutions we offer. In the first example, we see a gas spring rod that worked in contact with a corrosive fluid. Typically, this can be a lubricant or a cleaning emulsion. The change of the rod roughness did not allow the correct sealing, and that led to the gas spring failure. In the second example, we see a picture of a new seal on the left, together with a failed seal on the right. The seal on the right worked in contact with a lubricant that was not compatible with the seal material. The consequent dimensional deformation of the seal caused a premature wear of the sealing lid that could not properly seal the gas. For this kind of situations, special springs can perform compatibility tests if required. In this last example, we can see the effect of an environment with presence of powder that is typical, for example, of hot stamping dies. The presence of powder on the rod sliding surface can damage the seal and let the gas to be discharged. To avoid or at least delay the gas spring failure, Special Springs, together with Dayton, offers three different protective solutions: secondary wiper, SKUDO, and SKUDO-FLEX. Let's see the main differences. First of all, their working principle is different. While secondary wiper removes the contaminants from the rod surface, SKUDO and SKUDO-FLEX avoid the contact between rod and contaminant. Therefore, from a technical point of view, they are more efficient. Secondary wiper can be installed on all cylinder series. SKUDO requires a special grooves on the rod for the installation, so it is suitable only for GSFC and GSRS. And SKUDO-FLEX can be applied on all the cylinder series with body diameter bigger than 25 mm. For the installation, SKUDO is not suitable for cover flange and upside-down installations. The gas spring overall diameter change must be considered. That is bigger for SKUDO-FLEX, around 15 mm. The gas spring change in length has also to be considered, and here too, the change is bigger for SKUDO-FLEX, 10 mm. For the cylinder stroke, only secondary wiper requires to reduce it. let's see how the SKUDO-FLEX is installed on the gas springs. We will see the installation on a cylinder without collar plates. We need only scissors and Allen key. SKUDO-FLEX is supplied pre-assembled. The first operation is to put the SKUDO-FLEX on the gas spring and draw a reference line on the fabric part, roughly 10 millimeters lower than the body groove. We can cut with the scissors the fabric using the reference line as a guide. After cutting, we can proceed with the installation on the gas spring using the special screw supplied with the SKUDO-FLEX to mount the disc on the rod. After tightening the screw, the cable tie can be installed in the cylinder body groove. Then we can trim the cable tie excess length. And so the cylinder is ready for the installation in the die. SKUDO-FLEX is the newest product in the protective product range that gives a full protection to the gas springs, allows to reach longer lifetime, and is suitable for almost all the cylinder series.
Thank you, Francesco, for the detailed explanation. And here's a look at our warehouse. We always have a large quantity of gas springs in stock, and we will be happy to create custom inventories. Please feel free to contact us about this. Our warehouse allows us to achieve very short delivery times. Dear viewers, do you have any questions for us? If so, please feel free to ask them via the chat function. I just see one question what is coming in. Question is coming from Sven. The question is, what are the most common installation mistakes to lead to premature gas spring failure? Francesco, can you answer that, please?
Yes, of course. During installation, it is important to keep the gas spring supporting surface clean and free from chips, powder, and dirt. The installation on dirty surfaces can cause misalignment, local wear on the gas seal, and then lead to a premature cylinder failure. Also, the correct and balanced screw tightening is important to let the cylinder work on the correct position. We always recommend using a torque wrench for the installation of the screws.
Okay, thank you, Francesco. I don't see more at the moment. Another question is just coming in. The question is, in which situation would you recommend replacing a gas spring rather than repairing it? I think that's also better answered from you, Francesco.
You already explained before, and replacement is recommended every time safety feature is found deactivated. Furthermore, also when there is damage on the gas spring that can lead to a premature failure, for example, in case of alteration of the rod surface.
Okay, yes, thank you. We already had part of that in our presentation. Oh, there's one more. What are the limitations of SKUDO-FLEX? Are there environments or media where you would not recommend it to use?
The most important limitation is the temperature. With over 100 degrees, the durability can be reduced. For the media, we have good performance with lubricants, water, and chloride. Therefore, we do not notice limitations for the media.
Okay, thank you for that. At the moment, I don't see any more questions. So if also for all the viewers, if you have questions in the time after the meeting, no problem. You can contact us all the time, and we will be able to answer it. For the moment, I don't see anything which is coming in. So from that standpoint, I would say thank you very much for visiting our webinar, for watching us, and wish you a good time. Thank you.
Thank you. Bye-bye.
Bye.